Welcome, ladies and gentlemen, to this video lecture. So now we will move on to a new section called the limit laws. So there are a couple of general theorems that we can use to work with limits, and these are called the limit laws. So let me write down the limit laws. So let A be some real number, let L and M also be real numbers, and let F and G be functions defined on an open interval, containing A open interval, and this interval has a name. This interval is called I, and it contains A, and F and G are defined on this open interval containing A, except possibly at A. So they need not be defined at A, except possibly at A. At A. Okay. So, if we know something about F and G, then we know more. So this is the theme of the limit laws. So if we have that the limit as x tends to A of f of x is equal to L, and the limit as x tends to A of g of x is equal to m, then we know something, and we know a whole bunch of things. What do we know? Then the limit as x tends to A of f of x plus g of x, the limit of the sum exists and equals L plus m. So the limit of the sums exists and is equal to the sum of the limits. So that is number one. So this is what is called the sum law, or the sum rule for limits. So the sum law for limits. Number two. For every real number c, we know that the limit as x tends to A of c times f of x exists and equals c times L. And number three, the limit as x tends to A of f of x, g of x, exists and equals L times m. And this is, of course, the product law for limits. Product law for limits. And number four, if m is not equal to 0, then the limit as x tends to A of f of x divided by g of x exists and equals L over M. And this is, of course, the quotient law. Quotient law for limits. Okay. So here is the statement of some of the limit laws that we will study. So let us see here. If we know that some limits exist, then we automatically know that the limits of the sums exist, and the limit of the products exist, and the limits of the quotient exist. So this general theorem saves us from doing extra work. If we know that the limit of f exists and equals something, and we know that the limit of g exists and equals something, then we automatically know that the limit of the sum exists and what it equals. So this general theorem saves us from having to separately go and in every single special case to need to prove things like the limit of the sum of two functions, what it equals. Okay. And now, also, what you should notice here is previously what we did was we proved statements of this form. Now we are assuming that statements of this form are true, and we want to prove something like that. So previously what we had was we proved statements like this. Now we will assume that they are true, and that gives us, or those are sometimes, or let me say, they we need to be quite careful in making these assumptions. We are assuming the truth of quantified statements, and we have to be very careful with how we work with them. So we see here the statement of these limit laws. They are stated in the form of an implication. So if this, then that. So they are stated in the form of an implication. So we will assume these statements. We will assume the truth of these statements, and then we will have to prove these statements 1, 2, 3, and 4 that we have here. Okay. Before we jump into that, let me end this video here, and then we will have a discussion on how we should think about when, or what we should think about when we are assuming statements like these ones, when we are assuming quantified statements. But that we will discuss in the next video. I will see you in that video.